おはようございます。昨日の実績ですけど、昨日は燃料取扱機の荷重試験、無事終わりました。
This is the Tokyo Electric Power Company Holdings Incorporated Fukushima Daiichi Nuclear Power Station.
動作範囲の確認よし。動作範囲の確認よし。0歳でいこうよし。0歳でいこうよし。5時にお願いします。
In March 2011, the station suffered a severe nuclear accident during the Great East Japan earthquake and tsunami, and is now being decommissioned. Training is being conducted in the remote operations room to remove fuel from the spent fuel pool inside the reactor building. The fuel handling equipment includes 3 cranes that are operated by remote control.
左旋回します。左行きます。
35-year-old Nino Kyonosuke is giving instructions. The young engineer is engaged in the design, development, and operation of robots and other equipment.
A key focus is to make each movement with great care, ensuring there's no risk of contact between the cranes and other equipment on site. This is something that could not be confirmed during factory tests.
配管走ってるところをひたすら今見てるっていう状態です。
22-year-old Kaminuma Shiena works to manage the maintenance of plant machinery. She came to work at the power station out of a desire to contribute to recovery in Fukushima, her home.
I'll perform each task to the best of my ability to help bring about recovery in Fukushima.
Alps stands for Advanced Liquid Processing System. Alps is key equipment that removes radioactive materials from contaminated water generated when cooling water that has come in contact with fuel debris inside the reactor buildings mixes with rainwater and groundwater. 31-year-old Kurosawa Takumi inspects and maintains this equipment.
It's important to follow procedures, perform pointing and calling, and stop immediately if anything seems out of the ordinary.
34-year-old Kawamukai Koji is on Kurosawa's team.
Honestly speaking, there was a lot of pressure since an error with valve conformation or operation could lead to major equipment failures.
15 years have passed since the Fukushima Daiichi accident. This program shines a spotlight on the younger engineers responsible for the long-term decommissioning process and the challenges they encounter. The Fukushima Daiichi nuclear power station faces the Pacific Ocean. With 6 reactors on a large swath of land, Fukushima Daiichi was a major power supplier for the Tokyo metropolitan area. The tsunami resulting from the Great East Japan earthquake caused a loss of power. It became impossible to cool units 1, 2, and 3, and the fuel assemblies overheated and melted, thereby causing other structures inside the reactor to melt. These molten materials fell and solidified, becoming fuel debris. As the fuel assemblies melted and fell, large amounts of hydrogen was generated, which led to explosions in the reactor buildings of units 1, 3, and 4, damaging the facilities and dispersing radioactive materials. Since the accident, working conditions have significantly improved through decontamination efforts. In the majority of areas, workers now only need standard work clothes with simple masks. Between 3,600 and 5,000 people work on-site each day. In order to lower the risks associated with radioactive materials resulting from the accident, Decommissioning tasks include removing fuel from spent fuel pools, contaminated water countermeasures, fuel debris retrieval, and waste management. This kind of decommissioning is unprecedented and is being carried out by numerous companies and engineers.
As we move forward with the unprecedented task of full-scale fuel debris retrieval, which has never been done before, we will transcend the barriers of position and standing to build trust and collaborate with local entities and partner companies as one team so as to share information on objectives and issues while heightening safety in an effort to complete decommissioning.
4:30 a.m. A single car pulls into the parking lot. Every morning, crane operator Nino Kyonosuke parks here to transfer to a company bus that takes him to work. This is the office of the company where Nino works, located about 3 kilometers from the Fukushima Daiichi nuclear power station. His workday begins at 5 a.m. The day starts early for a reason. During the summer between May and October, employees report to work at 5 a.m. to avoid the danger of heat stroke when working in the dangerous afternoon temperatures. The cranes used to remove fuel from the spent fuel pool of Unit 2 is controlled remotely from this room. As the crane operator, Nino steadily makes preparations. Let's look at the conditions at Unit 2. Since there was no hydrogen explosion in the reactor building, it has retained its original appearance. However, the accident caused radioactive materials to spread from the containment vessel into the reactor building, and radiation levels inside the structure remain high. At the top of the 62-meter-tall reactor building is a spent fuel pool, where 615 fuel assemblies remain. A crane for removing fuel assemblies had originally been a part of this fuel pool facility. However, it was rendered inoperable by the accident, so figuring out how to remove the fuel was a major issue. Ultimately, the decision was made to begin development of a new crane. At that time, Nino was an employee of the Tokyo Electric Power Company working in the mechanical systems group, where he was in charge of tasks using robots.
I was frequently involved in deploying remotely operated robots to decontaminate areas where people could not enter and conduct survey investigations of high radiation zones.
In June 2020, an investigation of the Unit 2 spent fuel pool was conducted using a submersible robot. Its pilot, operating from a remote location, was Nino. July 2023. In recognition of Nino's skills in remote robot operation, he was dispatched to a partner company developing the new crane's technology. As a member of the development team, he proposed various ideas.
Drawing on my previous experience with remote operations, I proposed speed settings for safely operating the crane and gave suggestions on how to position and arrange the cameras used to monitor the entire system.
To install a new crane, the exterior walls of the reactor building would have to be demolished. However, this would release the radioactive materials into the environment. Therefore, the decision was made to instead create a small opening in the wall through which a crane could be inserted and installed above the fuel pool inside the reactor building. To accomplish this, a support structure the same height as the top of the fuel pool was built on the south side of the reactor building. The work platform measures 45 meters high, 33 meters wide, and 27 meters deep, and took approximately 2 years to complete. In May 2025, the first fuel handling equipment to include 3 cranes in Japan was finally completed. The fuel handling equipment was transported to the power station and placed on the work platform. This newly developed fuel handling equipment has 3 cranes situated compactly on a single trolley.
The fuel handling equipment has 3 cranes and sits atop this blue trolley. Each of the cranes performs a different task. The largest crane, the yellow one, is used to handle the on-site fuel transport casks that the fuel assemblies are to be put in. The orange crane is a specialized fuel handling crane that grasps the spent fuel assemblies and places them into the casks. And the green crane is used to open and close the lids of the casks handled by the yellow crane.
The procedure for fuel removal is as follows. The yellow crane picks up and hoists the on-site transport cask up to the work platform and places it on the trolley. Then, the trolley moves into the reactor building. Once the fuel handling equipment is inside the reactor building, the yellow crane lowers the cask into the spent fuel pool. Next, the green crane opens the lid of the cask. The orange crane then picks up a fuel assembly and places it into the cask. Each cask can hold up to 7 fuel assemblies. Once the assemblies are secure, the green crane closes the lid of the cask. The yellow crane lifts the cask back up and returns it to the trolley. The trolley moves back from the reactor building to the work platform, where the yellow crane is used to lower the cask to the ground and load it onto a specialized vehicle. The fuel assemblies are then transported to a common pool, thereby completing the procedure. The high radiation levels inside the reactor building make entry impossible, so countermeasures have been implemented.
We anticipate various potential problems and have formulated redundant measures to handle them. For example, the power supply has a duplicate redundant system. So do instruments for measuring boom angle and rotation position. They all have redundancy measures. So, even if one or more of the main instruments somehow becomes inoperable, there are countermeasures in place so the task can still be safely completed.
October 2025.
170度にして180度にしてってのを2回繰り返します。
After successfully completing tests of the fuel handling equipment on the gantry, plans were made to move it into the reactor building the following week. Due to the high radiation levels inside the reactor building, the fuel handling equipment operation must be performed from a remote location.
はい、150です。
On site, conditions may differ from what was verified during planning. We need to check if the crane can be operated safely in its current position and see at what speed it can be safely maneuvered. A key focus is to make each movement with great care, ensuring there's no risk of contact between the cranes and other equipment on site. This is something that could not be confirmed during factory tests.
Final adjustments are made before moving the fuel handling equipment inside the reactor building. Repeating the complex crane operations required to remove all 615 fuel assemblies is far too much work for Nino to complete alone.
Before beginning fuel removal, a special fuel removal team will be trained in the crane operations required. The ultimate goal is to remove all the fuel in the Unit 2 spent fuel pool, which will then be moved to a safe location. First, the special fuel removal team will have to gain the skills needed to remove the fuel assemblies safely.
Fuel removal is scheduled to begin after April 2026 in order to provide enough time for thorough training. Nino is playing basketball with his 5th grade son, Iori. Iori has recently joined a local team and is actively practicing.
I started playing basketball when I was in elementary school. I still play quite a bit for fun. Bringing my son along might have had some influence on him.
My dad is usually really nice, but when it comes to basketball, he can be strict. I'm not that good yet, but I think that I'm getting better little by little.
The time Nino spends with his son has become a precious opportunity to relieve the stress of his daily work duties. This is the mechanical equipment group at the Fukushima Daiichi nuclear power station. They are responsible for the maintenance management of mechanical equipment such as the pumps and piping used to cool the spent fuel inside the reactor buildings of Units 1 through 6, as well as the emergency diesel generators. Kaminuma Shiena joined the Tokyo Electric Power Company in 2022. She was 7 years old when the Great East Japan earthquake struck, and says that her experience in evacuation shelters was what led her to the work she does today.
Volunteers from outside the prefecture came to help, and they would ask if I was okay and say, "If you need anything, let us know." That made me really happy. It made me want to help people in the same way. And even after starting high school, I still wanted to work in some way to contribute to Fukushima's recovery. So I applied to join the Tokyo Electric Power Company.
These are Units 5 and 6. At the time of the accident, both were shut down for regular inspections, so no radioactive material was released. However, the tsunami that followed the earthquake damaged the facility, allowing groundwater to flow in. To prevent the power equipment in the basement from being submerged, this groundwater must be pumped out regularly. Today, Kaminuma is overseeing the work site where the water in the building's basement is being pumped out.
I had concerns about my abilities, but after being assigned to this group, I found everyone to be quite kind, and I'm able to enjoy my work. My duties involve identifying risks at the work site. For example, tripping. We identify where someone may trip and injure themselves and implement countermeasures to prevent it from happening.
When Kaminuma joined the company, she did not have any particular knowledge or skills pertaining to mechanical equipment. This is why she initially felt anxious about her job. However, over the past 3 years, she has received advice and support from her mentors and supervisors, and has become more positive after realizing the importance of working as a team. Kanno Satoshi is Kamimura's supervisor.
Because Kaminuma didn't graduate from a technically focused high school, I could tell that she really struggled. But she worked hard to communicate clearly with contractors and express her opinions with colleagues. She's a central figure in the younger generation of workers here.
Kaminuma's strong determination to bring about recovery in Fukushima continues.
As a local myself, I really want to hear the voices of the community, and I'll perform each task to the best of my ability to help bring about recovery in Fukushima.
An essential part of the decommissioning process is managing contaminated water. Contaminated water generated daily from units 1 through 4 is purified using the multi-nuclide removal equipment, Alps, and other systems. Treated water is diluted with a large amount of seawater in order to fully meet national and international safety standards before being discharged into the sea. This technical training center is about a 30-minute drive from the Fukushima Daiichi nuclear power station. Here, various training programs are conducted to ensure that the unprecedented decommissioning work can proceed smoothly.
目的、ろ過水槽ポンプユニット性能維持確認のため移送ポンプ切り替えを実施します。注意事項。
The training is led by Kurosawa Takumi, a team leader responsible for the maintenance and inspection of Alps. Kurosawa joined the company in 2017. Since 2024, he has been involved in decommissioning work at the Fukushima Daiichi power station.
Even a single valve operation error on site can cause equipment failure. It's important to follow procedures, perform pointing and calling, and stop immediately if anything seems out of the ordinary. The purpose of today's training is to get used to this process.
停止からナンバー2操作せよ。
はい、ポンプ選択、停止からナンバー2ですね。
その通り。
3、2、1、実行。
Receiving the instructions is Kawamukai Koji. He joined the Tokyo Electric Power Company in 2017 and worked at Fukushima Daiichi on groundwater pumping equipment and Alps-related construction. In August 2025, he trained at a partner company to improve his technical field skills and accumulate field experience to ensure a safer work environment as decommissioning continues into the future.
Because of this training, I can now better imagine what it will be like to operate valves in the field, and am confident that I can safely perform this task.
Kurosawa and Kawamukai's team are heading into the field to perform Alps maintenance. They remove their regular work clothes and put on coveralls to prevent radioactive material from adhering to the skin, full face masks to prevent internal exposure, and fully waterproof anorak pullovers to prevent contact with contaminated water. This gear places a significant burden on the body.
Even 1 hour of work wearing the anorak is much more physically demanding than I expected, regardless of the season.
Alps removes a variety of radioactive substances using adsorbents. After use, this material is collected as radioactive waste. Today's task entails filling the tanks with new adsorbent material.
Because the adsorbent material doesn't dissolve in water, overfilling can clog the pumps. So we need to monitor pump operation by listening to the sounds it makes while performing the work.
The adsorbent material is mixed with water and pumped into the Alps tanks.
Honestly speaking, there was a lot of pressure since an error with valve confirmation or operation could lead to major equipment failures. But thanks to my training and a careful review of the procedures, I was able to overcome that pressure and approach the task calmly.
The younger members of the team are working hard together. We want to continue to work as one team as we strive for recovery in Fukushima.
The retrieval of fuel debris from Units 1 through 3 will be the most difficult task in the decommissioning of the Fukushima Daiichi nuclear power station. In the fall of 2024, a sample of fuel debris was retrieved for analysis from Unit 2. The information gained through analysis will aid with the ongoing design and development of full-scale fuel debris retrieval methods and systems. We asked Nino, who continues to train for fuel removal, about his hopes for the future.
The fuel handling equipment was only made possible because of the cooperation between many people. To honor their efforts and not let anything go to waste, I plan to be thoroughly prepared for the task at hand and approach the work as part of our one team until the entire decommissioning project is safely complete.
The decommissioning of the Fukushima Daiichi nuclear power station is an unprecedented task. Over the decades-long process, young engineers on the front lines will overcome numerous challenges and see the task through to completion. This program was made possible by Tokyo Electric Power Company Holdings, Incorporated.